to 7 parts. So I need you first to go to section 2.3. We're going to be looking at a couple laws of logic. One's called the law of detachment, and the other is the law of syllogism. As we start putting these if-then statements together, there are certain patterns of thinking that are logical, and then there are other ones that are not logical. And probably some that you think maybe sound like they would be logical or not. There's just two patterns as far as information that follow logic correctly to come up with a conclusion. One is called the law of detachment, and the other is the law of syllogism. And after those, we'll take a look at what theorems are later in our chapter. We're going to be spending 3 days on sections 2.6 and 2.7, just doing some different things. Today we're just going to look at what those theorems are in that section. So first of all, again, I think we talked about what is inductive reasoning. So let's review or bring that up again. What is inductive reasoning? Inductive reasoning. We mentioned it probably about 15 minutes ago. What is it? Got your notes in front of you. Maybe it was chapter 1. Inductive reasoning. Samantha?
The process of reasoning that a rule or statement is true because specific cases are true and drawing a conclusion.
Okay, so examples, certain cases, that develops a pattern. So inductive reasoning was making a conclusion based upon a pattern. And we're going to be focusing a little bit of time on inductive reasoning, but more time on deductive reasoning. So what's deductive reasoning? We'll see this at the top of section 2.3. Deductive reasoning is the process of thinking using logic to draw conclusions from, not from patterns, it's from given facts, definitions, and properties. Now, given facts, that's not saying a bunch of examples. Facts are not examples. Facts would be maybe someone's age, or the year, or the date, or a definition of their specific pieces of information. Definitions, you need to recall definitions we've studied. Okay, what congruent segments are, complementary, supplementary, vertical angles, all those different definitions are going to be what we build on. Properties, we just did some of those on Friday. So those properties can be used to build things. Okay? So using those things in the reasoning process is what deductive reasoning is. Okay, so one of the laws of logic is called the law of detachment. Now, I put it in symbols, and then I put it with some shapes. If you're a visual person, maybe the rectangles and ovals help you see the pattern. If you can understand with the variables, the P's and Q's, that's what I probably will use most of the time. But the law of detachment uses a certain pattern for information. Okay? As long as you have this kind of information, then this is a valid conclusion. Law of detachment has an if-then. So if P then Q is going to be a statement we need as a fact, and that has to be a true statement. We also need P, which is the hypothesis. We need that to be a true fact. So if we have an if-then that is true, and the hypothesis part of it is true, we will correctly be able to support that the conclusion has to be true. So we're going to be looking for that pattern. So as we map out some things, we're going to be looking for an if-then statement. We're going to analyze what's the P, what's the Q. We're going to then see, does it tell us that the hypothesis is true? If not, it's not following the pattern. If it does have both of those, then the correct, therefore, the conclusion is going to be a true statement. Where does that come from? Do you remember this true-false chart? I showed you that once before and kind of said that if the hypothesis is true but the conclusion is false, that's how we proved a statement was false, a counterexample. Well, right now we're looking at a little bit different part of this chart. If the if-then is true, notice it could have been true 3 different combinations of information. But if the if-then is true and the hypothesis is true, notice down here the hypothesis was false. If the if-then is true and the hypothesis is true, the only line that fits that is when the conclusion then has to be true. These down here were the ones that didn't make a lot of sense to us. Remember that problem? If a cat is a bird, then whatever. And we said that that was a true statement because we couldn't get the hypothesis to make a counterexample. We couldn't get an example that way. So whenever the hypothesis is false, you can always get a true if-then. But if the hypothesis is true and the if-then is true, then the conclusion has to also be true. That's the law of detachment. So how's it go? I think that's what I was saying. Here's an example. If the Seward pool is open, then it is a warm summer day. That's an if-then. The Seward pool is open. That's a fact that we're giving in addition to it. So their conjecture or conclusion, is it correct to say that it is a warm summer day? These questions will usually ask, is it valid? Is the conjecture valid or is it not? In other words, is it valid? Does it follow the correct pattern of information? So we have an if-then. As you read up there, what's the hypothesis? What's the P part from the if-then? Seward pool is open. Pool open. And then the Q part, warm summer day. So from our if-then, another fact for the law of detachment is they need to be talking about the hypothesis. Pool is open. Did they clarify that the pool is open? Yes. And so it is following the correct pattern. The valid conclusion is it is a warm summer day. So what's up there does follow what's called the law of detachment. It fits the pattern for the law of logic. Let's try another one. In the World Series, if a team wins 4 games, then the team wins the series. The Red Sox won 4 games in the 2004 World Series. Is the conjecture valid? The Red Sox won the 2004 World Series. Now think of it as what's P, what's Q? What's P? Read the if-then statement. Okay. Win 4 games. What's the Q? Win the series. That's from our if-then. Okay, did they tell me about some team winning 4 games? Okay, so the Red Sox won 4. So the valid conclusion would be that the Red Sox won the series, which is the correct conclusion up there, conjecture. So valid. We're just analyzing the pattern. Does it have the right pattern? Sometimes these facts could be flip-flopped, but they need to come before what the conjecture is. Let's try the next one. If school is dismissed early, then Jenny needs a ride home from school. Jenny needs a ride home from school. Is the conjecture valid that school is dismissed early? Analyze the pattern. What's the P?
If school is dismissed.
Okay, dismissed early. Q? Okay, she needs a ride. Notice now it says Jenny needs a ride home. That's not clarifying the hypothesis is true, is it? So is it fitting the pattern? No. So is this a valid reasoning? No. It's kind of like thinking about a converse. If she needs a ride home, then is school dismissed early? No. Maybe she got sick. Maybe school's not dismissed at all. So that's why it's not a valid conjecture, because kind of the converse idea. You can't just switch the order and it still be a true statement. Try the one about the triangle. what's P, what's Q? Ask everybody to give me a thumbs up if it yes is valid, or a thumbs down if it's not. You just put it in front of your chest so I can see it and not everybody else can see what's going on. Is that following the pattern for the law of detachment? Show me your thumbs up or thumbs down. We have a little bit of both. More are saying no. So let's see. If the base and the height of the triangle are 5 and 12, that's the P. Telling you what the base is, telling you what the height is. Q is, the area is 30. So P is true. Is it telling me a specific base and height? No. So it's not following the correct order. So it was not valid. In other words, you could come up with a triangle with an area of 30 that doesn't have the dimensions 5 and 12. So it's not following the correct pattern. I think this is the last one on law of detachment. If a student passes his classes, then the student is eligible to play sports. Raymond passed his classes. Is the conjecture correct? Does it fit the pattern? Okay, again, thumbs up or thumbs down? Which one? Thumbs up or thumbs down? Valid or not valid? That one is valid, correct. Passing the classes is the P part. Eligible to play sports was the Q part. So one correct thinking is law of detachment. Another one is called law of syllogism. Kind of a fun word, syllogism. This one reminds me of the transitive property. Law of syllogism. If you have if P then Q statement and if Q then R statement. Now there is a reason that they put the Q in both places, because on one statement it needs to be the hypothesis, on the other it needs to be the conclusion. But that's your linking idea where you have that. So if you have those if-thens, then what you can come up with as a valid conclusion is that an if P then R statement can be made out of that is true. Have you read or are you familiar with the books like if you give a moose a muffin, if you give a mouse a cookie, if you give a pig a pancake? Those are a good illustration of law of syllogism. If you give a mouse a cookie, then it's going to want some milk. If he wants some milk, then he's going to need a glass. If he needs a glass, then he's going to need a napkin, whatever the order is. So all of these if-thens that kind of take you along a long sequence, basically the moral of the story is if you give the mouse a cookie, then whatever happens at the very end, he's going to need a trash can or whatever. He wants another cookie? Okay. So there's a sequence of things along the way. Okay? That's a law of syllogism type of statement. So now we're going to analyze. And what I try and do, yeah, those are kind of fun books. When I analyze it, I try and figure out what the Q is, because then that helps me know if it's at the end of the sentence, the P was before it. If it's at the beginning, then it's the R following it. So let's see if we can pick out the repeating Q idea to help us analyze the sentences. Okay, here's your first example. If a figure is a kite, then it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. So is it correct, valid to say if a figure is a kite, then it is a polygon? Yes. Okay, tell me what's the P, the Q, and the R. The P is the kite. Q is quadrilateral. And quadrilateral repeats in another sentence. And the R is polygon. And so we come up with an if then that. If it's a kite, then it's a polygon, it does fit the pattern. Correct, or question? Okay, try the next one. Analyze the parts to it. Let's slide this row up about 6 inches, a foot, something like that. Slide up, slide up, slide up. Okay, so now we'll test this and see what's going on. If a number's divisible by 2, then it's even. If a number's even, then it's an integer. Conjecture, if a number is an integer, then it's divisible by 2. Determine whether it's valid or not valid. Does it follow the pattern of syllogism? What's the P? What's the Q? What's the R? What's the P part? Cody? Okay. What's the Q part? And what's the R part? Nope, that's not R. That was Q. Okay, so then at the end, does it put the right things together? The P is P, then R? No? It says if R, then P. Correct. Based upon what he said, it is not valid. They've got this backwards. They should have had, if it was divisible by 2, then it is an integer. So that one was not valid. Make sense? Let's try the next one. Okay, I want to see everybody writing down. What's P, what's Q, what's R? And see if it's following the pattern. If you can make it fit, and it comes up with the correct conclusion statement. What's the P, what's the Q, what's the R? What's the P part? Mammal is not the P.
No, if an animal is a mammal, then it has.
What's the P part?
Animal.
Having hair? No. How do I know what's what? Do I see a repeated idea in those first 2 sentences that we started with? Mammal repeats, right? It's the end of one and it's the beginning of the other. That's the Q part, mammal. So Q is mammal. so which sentence has the conclusion as mammal? The second one. So what's the P part? What's the if part of that second sentence? Dog. An animal is a dog, then it is a mammal. If it is a mammal, then it has hair. Hair is the R part. Why wasn't mammal P? Because it repeated. I kind of flip-flopped those two sentences for you this time. So what should be the conclusion? The correct conjectures should say if it's a dog, then it has hair. Is that the correct thing? Yes, it was. Making sense?
I could bring one snake in particular that is technically a mammal. It doesn't have hair.
So you're saying that, well, let's see. I'm just using those as the true facts, I guess. I wasn't analyzing it any further. I was just looking for a pattern in the information for you. Okay, question picking out the pattern, did it trick you? Did I flip-flop those two sentences? So watch out for that. And again, how did I know what the Q part was? I read through the sentences and saw mammal was talked about both places. Now what if mammal was in the conclusion of both sentences? If mammal was the conclusion of both sentences, it would not fit the correct pattern for law of syllogism. Because it would, to do syllogism, it has to be the conclusion of one sentence and the hypothesis of the other. Just like the transitive, it has to link it together in that way. Now this is a little bit different. I'm not giving you a conclusion. I want you to make a conclusion. So I'm giving you, it's like back on this, if I didn't give you the conjecture, I want you to make a conjecture. You can either use law of syllogism or detachment, whatever fits the problem. And I want you to come up with what a correct conjecture would be. So let's look at this one. If a polygon is a triangle, then it has three sides. If a polygon has three sides, then it is not a quadrilateral. You think it fits law of syllogism or detachment better?
Detachment.
Okay, why would you say detachment? Does it have an if-then, and then a hypothesis fact that is stated as true? Doesn't it have two if-thens?
No.
If the polygon's a triangle, then it has three sides. If a polygon has three sides, then it's not a quadrilateral. That sounds like two if-thens. What's the Q part? What's the repeating?
Polygons.
Three sides. Okay, three sides, three sides. So let's figure out the rest of it. First sentence has the conclusion as three sides, so evidently P is, polygon is a triangle. The second sentence starts out, if a polygon has three sides, then it's not a quadrilateral. That's the R part, not a quadrilateral. So what kind of a conclusion or statement can we come up with using syllogism as our law of logic? If the polygon is a triangle, then it is not a quadrilateral. If the polygon is a triangle, then it is not a quadrilateral, would be the correct conclusion, or conjecture, whatever you want to state it as. So again, we had to analyze what's the P, the Q, the R, and put it together using one of those laws. Making you think again, some of you don't like to think. Okay, I kept those two if-thens up there, but I gave you another fact that you could use. I'm saying polygon P is a triangle. So now you can maybe do something with that fact in one of the if-thens. If you know it's a triangle, then if it's a triangle, then it has three sides. Now you have a triangle. So what can we say about polygon P? Polygon P has three sides. So what did we use to do that? Well, we use this fact and this if-then. That's setting up the law of detachment. An if-then and a hypothesis. So we can make the conclusion from the if-then, it has 3 sides, it was polygon P. So one thing you can say is polygon P has 3 sides. If you want to go further than that, once we figure out it has 3 sides, you can use the other if-then to help you out. If it has 3 sides, then it's not a quadrilateral, so you could also say that polygon P is not a quadrilateral. So on some of the problems, you're going to make up the statement. Okay, so think about these and see what you could tell me based upon that information. Can you give me a fact that I don't specifically know yet? What can you tell me about angles A and B?
They're supplementary.
They're supplementary. What facts are you putting together to come up with that? Which parts? Part 1, 2, or 3?
3.
You're using 3 and
3 the other ones.
I think 1, wasn't he? He's using that they add up to 180, and then he's using if they add up to 180, then they're supplementary. So he's using this fact and that if-then to do a law of detachment. So I think what Tanan said was, which one did he tell me? A and B are supplementary? That's one thing you could have come up with. If you went further, now that you know that they're supplementary, you could use the second if-then and say that they are not the angles of a triangle. And this was the syllogism one that we did on the last screen. So you're trying to put the facts together in a certain pattern to do the law of detachment or syllogism. Okay, and one more sample from this section anyway. Okay, look at all those if-thens, or 2 if-thens and 1 fact. Draw a conclusion and tell me what law of logic you're using. Are you using law of syllogism or detachment? We know that x plus 3 equals 12. So where's an if-then that helps us out after we know that? The second one. So since we know this is true, we can conclude 2y equals 4. Once we know 2y equals 4, what can we conclude also? Z equals -1. So what were we using when we used this true fact and this if-then? That was detachment. And then when we used that with the first one, we did detachment again. So we probably did detachment twice and didn't really do syllogism. So what you're looking at in that section is just what's the pattern for the information. Okay? You have to analyze what's the P, the Q, the R, make sure that it follows the correct thinking. If they mix things up, like a big mistake sometimes they do is put the Q here and the P here, that's in the wrong order, can't do the law of detachment there. All right, touch 2 walls and come sit down again to do section 2, 6, and 7 theorems. Get up and touch 2 walls.
So that's a key one, it's not more. Stuff wrong.
All right, get your brains going again. Okay, in section 2.6 and 2.7, what we're gonna focus on today is what are the theorems and postulates saying? So we did 2.5 on Friday. So you'll need to find the part on 2.6 that first says what a theorem is. A theorem is any statement that you can prove is true. So we're turning those conjectures into theorems to prove them. Okay, so that was the definition of a theorem, but the rest of that page we're not going to fill out today. So flip the page to where the actual theorems are at. See the 2.6? There's 4 theorems in 2.6, and then we'll turn to 2.7 that has 3 theorems. And our goal is to understand what the theorems are saying and be able to use them on some sample problems. Okay, the first one just is called the linear pair theorem, so as you start learning it, you'll need to associate it with that title. That's easier than saying the whole thing. Linear pair theorem, if 2 angles form a linear pair, then they are supplementary. 2 angles form a linear pair. How would you know when they form a linear pair? They equal 180. Just because 2 equal 180 doesn't mean they're a linear pair. Because I could have a 25-degree angle over here and a whatever angle over here, and they're not a linear pair. What makes 2 angles a linear pair? What was that definition? Okay, that's close to what it said. If they were adjacent and form a line. The name linear pair comes from forming a line. So you might have a picture like that in the diagram. If there's a picture where those 2 together make a line, you should know that's a linear pair. Now the theorem says if that's a linear pair, then they're supplementary, which supports the fact that if this is 50 degrees, and this one is 130. 50 degrees and 130. A linear pair, they're going to be supplementary. So here's a sample problem like what might be in the textbook. Clark, would you please sit in the front desk? All right, while he's doing that, find the value of x and the measure of each angle in this one. This should be an example for the theorem that we're on, that a linear pair of angles are supplementary. Linear pair of angles are supplementary. What does supplementary mean? That should help you set up your equation. To figure out if you're setting up an equation that's right, are you setting up that the 2 angles are supplementary? Supplementary means, what do you mean? Add up to 180. Okay, so have you added the 2 angles up there and put that it equals 180? Not that they're equal to each other. They add up to 180. Did that right, let's see, solving, 6x plus 15, x was 27. Okay, now the directions also said, and find the measure of each angle. So now if you substitute back up into the problem, I I got 54 degrees and 126 degrees. Did those end up supplementary? Did they add up to 180? Notice, yes, they did. I notice on my notes, I put a hypothesis and conclusion. So let's back up to the theorem a second. Some of you are kind of stumped on what to put. Okay, what's the hypothesis? Yes.
If two angles form a linear pair.
Okay, two angles forming a linear pair. That's your hypothesis. So you can only use this theorem if you have two angles forming a linear pair. If you don't have that, law of detachment says you can't do anything with it. The conclusion, the two angles, are supplementary. Don't interpret what supplementary means. That would be the next step in the thinking process. You know, when we did the step-by-step on algebra, the step-by-step when we do the geometry is this theorem would get them to be supplementary. Then we could write our equation based on the definition of what supplementary means. So kind of the step-by-step is what we're going to eventually get to. So that's what to do on your hypothesis and conclusion. All right, this one is called the congruent supplements theorem. The hypothesis has a lot of stuff in it. If two angles are supplementary to the same angle or to two congruent angles, all of that is the hypothesis. Then the conclusion, the two angles are congruent. Two angles supplementary to the same angle. So let's try and set up an example. Let's say we've got angle 1 as a supplement to angle 2. And then angle 5 is going to be a supplement to the same angle, angle 2. That would be the hypothesis in an example. What's the conclusion say we're going to have? Then the two angles are congruent. What two angles? 1 and 5. So out of this, the theorem is saying we should get angle 1 congruent to angle 5. Let's check it out with some numbers and see if it makes sense. I'm going to list angle 1, angle 2, angle 5. If angle 1 is 70 degrees, what's angle 2? 1's a supplement to 2. 110. Together they had to make 180. And angle 5 is a supplement to angle 2. Here's angle 2. What would its supplement be?
70.
70. So did we end up with angle 1 congruent to angle 5? Notice we did. All right, so you go through the example that I have up there. Angle 1 and 2 are supplementary, 3 and 2 are supplementary. If angle 1's 52, what's angle 3's measure? If it helps, write down your angles. So you can fill in how much each one measures. What's 3 equal? Is it 52? I think it is. Because 2 was 128, and then 3 is supposed to be a supplement to that 128. Yes. So it should have worked out by the theorem that in that situation, 1 and 3 were the two congruent ones. Yes. Because of the fact up there that said 3 and 2 are supplementary, So these two have to add to be 180. These two have to add to be 180. Okay, so I just subtracted. All right, next one. This one's a real simple one. All right angles are congruent. If you wrote that in if-then, it would be if there are two right angles, so your hypothesis is you have two right angles. Conclusion, they are congruent. The angles are congruent. Does that make sense, that all right angles are congruent? Because they're all 90 degrees according to the definition of a right angle. And how do we know they're congruent then? What's congruent mean? Same. When it's angles, would be same degree measure. So since they're all 90, 90s are all congruent, that should make sense. So a simple example, if angle 1 and 2 are both right angles, what can you conclude about them according to the right angle congruence theorem? And how do you write that?
Angle 1 equals smoothly on top.
Okay,
Angle 2.
correct. Okay, so it's just a simple they are congruent. All right, next one is called the congruent complements theorem. This one we were doing up here with the angles supplementary to the same angle, this theorem is almost the same, but it's complementary to the same angle instead of supplementary. So what do complements have to add up to be? 90 degrees. Okay, so we need two angles complementary to the same angle, or let me talk about the parenthesis part, or to two angles that are congruent. I think that's how I did the example. So let me just bring up the example for you. Okay, so I've got 1 and 2 being complementary. I've got 3 and 4 being complementary. So notice that in this sample, I don't have angles complementary to the same angle. One's complementary to 2, one's complementary to 4. But I also put 1 and 3 are congruent. So I guess thinking it backwards, if 2 is a complement to 1, 4 is a complement to 1, 1 and 3 are congruent, we should get 2 and 4 being congruent. Let's see how that works out. Angle 1's 52 degrees. What other angle can you figure out? 3? It's 52? Because we said they're congruent.
This one's 28, 38.
2 and 1 are complementary.
38.
38?
Not 30.
They have to add up to
38. Oh,
90.
30.
Yeah, all you make me sin against myself.
3 and 4 have to add up to 90.
38.
38. So we got angle 4 to be 38 degrees. And it ended up being congruent to angle 2. Okay, turn the pages to your 271.
Good to know, all these things tomorrow.
No, these are not on tomorrow's quiz. These will be on the test, but not on tomorrow's quiz. All right, this one is called the common segments theorem, mainly because we're adding a common segment length onto both of the ones we start with. So it says you have to have, for your hypothesis, the collinear points like A, B, C, D arranged in that order. So your hypothesis would be that picture basically. Got a hypothesis conclusion? Find where these theorems are at? Okay.
Oh.
So the hypothesis would be the picture and the fact that A, B, and C, D are congruent. Now what the conclusion, look at what segments are named. AC's length and BD's length will be the same. So if I have that picture, let's put some numbers. I want these two to start out the same length. So let's go 10 and 10. We'll make this middle part 25. So what is AB's length? Would you take the 10, or excuse me, AC is what I meant. AC, you would take the 10 plus 25 to get 35? And how about BD? Says this one will end up the same. 10 plus 25, so 35. What if I change this middle part to be just 20? These two still end up being the same? 30. 30. 28. 38. So by adding this common segment to each of those shorter ones that we started with, we get the longer ones to always be equal. It's kind of like the addition property of equality, but it's not exactly written the same way. So that's called the common segments theorem. Here's an example. How long would AC be? What would BD? AC is 28 and BD 28. They ended up being the same. You're adding the same amounts together. Vertical angles theorem. Again, a simple one. Vertical angles are congruent. What's the picture going to look like if you have vertical angles? Maybe put that in your hypothesis. What's the picture look like with vertical angles? You need to look back at the definition. Vertical angles. Two lines that intersect. Vertical angles are across from each other. So if I knew this angle as 60 degrees, according to this theorem,
That's actually
this one's 60 degrees also. Vertical angles are congruent. Here's an example of a problem that might be in your book related to this theorem. How would you find x?
7x minus 28 equals 5x plus 1.
They have to equal each other. Correct. That's what our theorem's saying. So do a little algebra right now. Put your 7x minus 28 equal to 5x plus 4. You're solving. And find the measure of each angle after you think you know what x is. Getting it solved? X is 16. There's my solving. Subtracted 5x and then added 28. When I substitute the 16 up into the problem, I got an 84 degrees for each one. That verifies that they were congruent, that that's the right solution. Problem? Yeah, there is none. Okay, question on that theorem? Vertical angles are congruent. We use that one a lot. And students often think that it's the vertical angle definition. Oh no, the definition really just tells me that they're across from each other. It's the theorem that tells me that they're congruent. All right, and the last theorem, Alyssa wants it to have a name. Well, not all theorems have a good name. This one does not have a name in our textbook. So what they do is, see this little shortcut handwritten thing at the end here? This is basically a short summary of what the theorem's saying. So if you know the theorem, that might make sense. So it says if two congruent angles are supplementary, so what we need, what's the hypothesis? You need two angles that are congruent and supplementary. Then each angle is a right angle. So your conclusion is both angles are right angles. Now think about that a little bit. If you have two angles that are congruent and supplementary, they have to be the same and add up to 180? Would they have to be 90 and 90? Which is what your right angles would be. Have to be congruent and supplementary. So their little shortcut, to me it's saying if you have congruent angles that are supplementary, then there's right angles, which is basically a summary of that. Could we come up with a name for the theorem? We probably could, but we might not realize that a later theorem, you might use the same title on that one as what you're calling this one, is why they're not giving you a name. So some we're just going to learn by number, 273. Or else just learn that the wording. If two congruent angles are supplementary, then each one's a right angle. So sorry, there's some that don't have a shortcut. Here's an example. If angle A and angle B are supplementary and congruent, what can you conclude about them according to this theorem 273? Tell me specifically, what can I conclude?
They're both right angles.
Okay, so you would say that angle A is a right angle and angle B is a right angle, just to clarify what you mean by they.
The angle A and angle B, 180.
That's not what it said in the theorem. What it said in the theorem is they are right angles. Now if you did more with that, you could maybe come up with something different, but the theorem doesn't say anything besides they are right angles. So I'm going to try and keep you step by step, so you're only doing one thought at a time. All right, problems that we'll do. First, you're picking on a little bit of law of syllogism, law of detachment. So those are on page 91. 4 to 8, 11 to 13. Then the theorems.
Is this on the iPad?
It should be, but I don't know that it's grouped correctly, so you might need to make sure, just write it down so that you know which parts are all today. So we did some law of detachment, law of syllogism, that was section 2.3, and then these are related to the theorems from sections 6 and 7. Reminder that tomorrow's quiz is really